everyone. In this video tutorial, we're going to look at relations and functions. We're going to look at how relations are sorted to form tables, which we can plot graphs from, and then we'll talk about functions. So stay tuned. A relation is defined as a set of ordered pairs that obeys a particular rule. Now, later on, we'll get more into the rules, but the bulk of the work has to do with plotting a table based on what a variable is mapped onto. So for example, if x is mapped on to 3x plus 5 and the domain, remember when we do graphs, we talk about domains. The domain x is an inequality minus 2, which is less than or equal to x, which is less than or equal to positive 2. Now, this statement here, x is mapped onto 3x plus 5, is going to help us plot our graph. And this domain is what we'll be ruling our x-axis to be. It's going to start from minus 2, and you're going to end at positive 2. So the values between minus 2 and positive 2 will be this. Minus 2, minus 1, 0, 1, 2. And we stop there, right? In order to calculate the coordinates for x and y, we need to rule a table. And the table is really easy to draw. We have the x column and we have a y column. So you draw your table. And just bear with me while I draw it. We have the x column. We have the y column, right? And then we have the rows. So just rule it up and I'll show you what labels to go in which part of the table. Okay. And I will start to rule it, enter my data then, because I don't want to draw too much table, if you understand. Right. So this is the x column and it starts from minus 2. So minus 2, minus 1, 0, 1, 2. Right. And you continue drawing a table based on that now. So you'll know exactly where to stop. Now, it's easy when you have a ruler and a pencil, but using online platforms, it makes it a little bit harder for me. We have now to calculate to find for y, and we put y on this column. But in order to find for y, we have to put out this statement here, 3x plus 5. And we will label it 3x plus 5. If you remember from our formula y equals mx plus c, we know that this is the plus c, which is a constant value. So we will just remain, this here will remain plus 5 throughout the table, right? And this is what we will use. So the y value, this plus 5 is like a constant value, it remains the same. When we come here now, we have to multiply what's on the top columns here by this x value here. So minus 2 by 3 is going to give me minus 6. Minus 1 by 3 will give me minus 3. 0 multiplied by anything will give me 0. 1 by 3 is 3. 2 by 3 is 6. Now we work this out. We have minus 6 plus 5 will give me minus 1. Then we have minus 3 plus 5 is going to give me 2. 0 plus 5 is going to give me 5. 3 plus 5 is going to give me 8. 6 plus 5 is going to give me 11. So when we look at this table carefully, we see here that these are the x coordinates, right? And from the bottom part of the table now, we see that this is the y coordinates, right? And when we get the range, when we get the x and the y value, we could plot it in figures that is easy to represent on a graph. So let me show you that now. So if I have, look at the table carefully, the notation x is mapped on to 3x plus 5 means x is mapped on 3x plus 5. So you write in the statement, the notation x is mapped on to 3x plus 5 means x is mapped into 3x plus 5. Hence, we did the table before, which is this table here, right? So we put the values for x based on the domain, and we plug in the 3x plus 5 in which x is mapped onto, and then we multiply it, and then we work it out by adding it, right? Hence, we get the y coordinates. So from this, we can write the ordered pairs in the form of x and y, and we'll get from the table now, we're going to get -2, and I'm going to circle it here, and then I'll put it in coordinate perspective for you. So we have -2, -1, -1, 2, 0, 5, 1, 8, and 2, 11. And when we put it in graph coordinates now, we can order them x and y in this way, coordinate way for the graphs. And we will say -2, -1 from the table, -1, 2, 0, 5, 1, 8, and 2, 11. So these are the x coordinates, these are the y, in that order. And from this now, we can plot a graph. The highest point on my y-axis is 11, and the lowest point is -1. So I could plot in that range. The highest, my x will remain based on the table, right? So we can go ahead now and plot a graph. You rule up your x-axis, and you can bring it down a little lower because the y-axis goes up to 11. And then you rule your y-axis. And very importantly, you label your axes. So we have the y-axis, the x-axis, we have 0. We start here with 1, 2. You could go on to 3, 4 if you want, but our table stops at 2. And then -1, -2. Then we go here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this is not accurate because I don't have graph paper, but you get the image, right? And then we have here -1, and you could just write -2. And now we plot in our points where x is -2, y is -1. So x is -2, y is -1, that is around here also. So you put a point, right? Next one, where x is -1, y is 2. Y, 2, it touches here. Where x is 0, y is 5, so that is on the 0 line. Where x is 1, y is 8, so that's around here. And where x is 2, y is 11. And when we connect the points, you should get a straight line. Now, not all the time you'll get a straight line. Your graph will depend, but this one I got a straight line. And in this graph now, I can write x is mapped on to 3x plus 5. Okay, so this is how we go from determining a relation in which x is mapped on to 3x plus 5, and then I could go further and plot my graph. Okay, so I can go a little further now and show you the relationship diagram or the arrow diagram, and it is very simple. The relation x is mapped onto 3x plus 5 can also be shown on an arrow diagram. And the arrow diagram looks like this. You have your x values, you have your y values, and you list them. -2, -1, 0, 1, 2, and then I have -1, 2, 5, 8, 11. They are usually sorry about that. They are usually in like circular, like little ovals, and then we plot. And then we draw the arrows. So -2 is mapped on to -1, -1 is mapped on to 2, 0 is mapped on to 5, 1 is mapped on to 8, and 2 is mapped on to 11. So here I have a 1-to-1 relationship. Okay, so this is how we show relations. You are usually given a domain for x, and this is what starts your table. Then the relation is given on what x is mapped onto, and this is what you multiply the values of x by and add the consonant value to obtain the value for y. Right? So I have a question now that we will work together. And the question goes like this. Draw a relationship diagram or a relation diagram. Anyone is fine. It shows relations for the relation defined as follows. I'm going to write that in a different color. The relation and the domain. Sometimes they give you the domain in an inequality form. Sometimes they give you the figures. Either way, it's not hard. So x is mapped on to 2x plus 1. And the domain for this goes from -3 to +3. So -3, -2, -1, 0, 1, and 3. 1, 2, 3. Sorry. Right? So we have the relation here and the domain here. So the first thing we want to do is plot our table. And to plot a table is very easy. You draw a table. You don't have to be too big, but make sure it's clearly defined. We have x, we have y, and we have the function. It is mapped. The relation, sorry, it is mapped onto. So 2x plus 1. Let me write it a little lower. Plus 1, right? And we have our x values, -3, -2, -1, 0, 1, 2, 3. And then we draw in our lines now. So just continue ruling your table and then work it out. Now, this is a very nice topic to deal with in math, especially for CXC, because it's a good way to get nice marks, right? It's not a topic to really tax your brain. It's just something for you to remember how to calculate. And we start by, what I like to do is keep a consonant value. So you just keep listing all that. And this is 1. So add 1. And then we multiply our x's. -3 by 2 is -6. -2 by 2 is -4. -1 by 2 is -2. 0 by 2 is 0. 1 by 2 is 2. 2 by 2 is 4. 3 by 2 is 6. And then we have -6 plus 1 is going to give me -5. -4 plus 1 is going to give me -3. -2 plus 1 is going to give me -1. 0 plus 1 is 1. 2 plus 1 is 3. 4 plus 1 is 5. 6 plus 1 is 7. So from this now, I could pull out my x and y coordinates to plot my graph, right? So my x and y coordinates will be -3, -5. So in x and y form, When -3, where we have -3, we have -5. Where we have -2, we have -3. And you just put them in the brackets, right? And where we have -1, we have -1 on both x and y. Where we have 0, we have 1. Where we have 1, we have 3. Where we have 2, we have 5. Where we have 3, we have 7. And this is how we determine this. So you could plot your graph and show your relationship. And your relationship diagram, again, is just the two bubbles with the numbers and the values in between, right? So our values, I want to put it on the same page. Our values for x and y, I'll just use a different color. We have x, we have y. Our values for x is -3, -2, -1, 0, 1, 2, 3. Our value for y is -5, -3, -1, 1, 3, 5, 7. And look at this. You can draw them in, well, they normally circle it like this. It's easier to show the two properties when you circle it. Forgive me, my handwriting is bad with this. So -3 is mapped onto -5, -2 is mapped onto -3, -1 is mapped onto -1, 0 to 1, 1 to 3, 2 to 5, and 3 to 7. This is also a 1-to-1 relation. Okay, the only thing I didn't do in this question is plot the graph, but the graph is pretty straightforward once you have the coordinates. Now, this is not a difficult topic. It is actually very simple when you think about it. So this is the basic of what we're going to do now. So let's continue. We are going now to talk about functions. A function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. Okay, and there are different cases to deal with. We show that we have one-to-one relation. We show that we have many-to-one relations, and then we can show that which is not relations and which is not a relations, what is considered a relation but not a function, and so forth, right? So we're going to get into that now. So a function is defined as a relation in which each element in the domain, which is the X domain, is mapped onto one and only one element in the range. So we have case 1, which we did before. And that is a one-to-one relation. So I have a little note here to recall what we did before. So recall X that was mapped onto 3x plus 5 is a one-to-one relation. This is a function and we write the linear function as f of x. So f of x is mapped onto 3x plus 5, or we could write it like this. F of x is equal, to 3x plus 5. And this is when we label them as a function. Note that f of x mapped onto 3x plus 5 means the function of x is 3x plus 5, right? So that is what f of x means, function of x. So this was case 1. We did it before, where we mapped on x to 3x plus 5, and this is where one x element has one relation to a y element. And we can write the linear functions as f of x is equal to 3x plus 5, which means the function of x is 3x plus 5. So this was a straightforward case, case 1. Now we move on to case 2. Case 2 gets a little bit tricky, and it has some square roots and square root signs and so forth, but it's nothing intimidating. So case 2. This is many-to-one relations. So consider x is mapped onto x squared plus 2x minus 5, and the domain for x is minus 2 less than or equal to x, which is less than or equal to 2. So then from this now we can say the values of x is minus 2, minus 1, 0, 1, 2. Okay? So a table of values for this particular relation for this particular relation, y is equal to 3x squared . Sorry, I forgot to put a 2 here, a 3 here, right? So relation 3x squared plus 2x minus 5 will be this. The table now will look a little different. We would have our x value, in which we would have our x squared values, then we'd have our 3x squared, and then we'll have our constant plus 2x, and then we'll have minus 5. Then we'll have our y value. So our table will start with our x value to be minus 2, minus 1, 0, 1, 2. And when we calculate now, so if you want, you could go ahead and rule up your table and bring them down. It will help you to understand when you rule your table. Okay. Again, it's not neat, but I'm trying my best. Right, so to get the x squared value now, what we need to do is multiply minus 2 or square these numbers. So first we square these numbers. So 2 2s are 4. Minus 2 by minus 2 will give me 4. 1 by 1, negative 1 by negative 1 will give me 1. 0 remains 0. 1 by 1 is 1, 2 by 2 is 4. Right? From this now, I have to multiply. I'm not going to use these values. I'm just squaring these values to get the x squared value. From this now, I'm going to multiply all the x squared values by 3. 4 by 3 is 12. 1 by 3 is 3. 0 by 3 is 0. 1 by 3 is 3. 4 by 3 is 12. And then I have to do the same with my plus 2x value. right? 4. To get this center value here, I forgot to put my consonant, so just not to time me up, put my consonant and then you work the center with x. Okay, so 2, -2 now, so we use to mark these values now. -2 by +2 is going to give me -4. -1 by +2 is going to give me -2. 0 by 2 will give me 0. And 1 by 2 is 2. 2 by 2 is 4. And that is how I found my x values. Now the x squared values will multiply with the x squared here. The x values will multiply with the x here, and the consonant value will remain the same throughout. So now we can say 12 minus 4 is 7. 12 minus 4, sorry, is 8 minus 5 is 3. 3 minus 2 is 1. 1 minus 5 is -4. 0, take away 5, -5. And 3 plus 2 is 5. 5 minus 5 is 0. 12 plus 4 is 16. 16 minus 5 is 11. And from this now, we have our x and our y values. Now, we're not using the x squared values to plot any graph, okay? We're going to work with these values. So where I have -2, I'm going to have 3. So -2, 3. Where I have -1, I'm going to have 4. -4, sorry. Where I have 0, I'm going to have -5. Where I have 1, I'm going to have 0. Where I have 2, I'm going to have 11. And this is my x and y value, right? And this is what we use now to plot the graph. These are the coordinates for that graph. Well, I can plot that graph, and it's going to be we can plot the graph. So let's do that. So you're going to rule up a graph now. Remember, you can pause the video and take your notes. And the graph will be -8 on the x-axis and up to 14, sorry, on the y-axis and up to 14. And I will go 4 and 4 on this side. We don't have to go 4 because our values are very small for x. So let's start. So we have 0, 1, 2, 3, -1, -2, -3. And then I could plot my y. My y is going up to 14. I don't need to, I could go 1, 2, 3, 4 up until 14, but it makes better sense if I go 2, 4, 6, 8, 10, 12, 14, 16, and this is y. This is x, right? And here we'll go -2, -4, -6, -8, right? And then we plot our points. So our points now are -2, where x is -2, y is 3. That's about here, so between 2 and 4. Where x is -1, y is -4, so that's here. Where x is 0, y is -5, so that's here. Where x is 1, y is 0, so that's here. And where x is 2, y is 11, and that is up here between 10 and 12. And if we connect our points, I'm going to do that in a different color. You're going to have it coming down so, and then curving up here, and then it goes. So this graph made a curve. Now, this is not accurate because it's really hard to do this on a digital platform, right? So this is our graph for this relation. X is mapped onto x squared, 3x squared plus 2x minus 5 with the domain minus 2 to 2. Okay? And for each value of y, we get so for each value of y, we get 2 corresponding values for x, right? So this is y. So if you look on your graph, if I cut it where the endpoints reach, where y is equal to 3, x is equal to approximately 1 and 2/3, and the next value for x is on this side, and it's approximately 1 and 1/3. Okay, so we have one value for y and two values for x, one value here, and the only value for y up here. So this was a different table to plot. But now, if we draw a relation diagram, we need to include these two values here, and I'll show you why. Okay, so let's draw a relation diagram, and it will look something like this. You're going to have minus 2, minus 1 and 2/3 from here, negative 1, 0, 1/3, 1 and 1 and 1/3. And our y values that it plots onto is negative 4, 0, and 3. Negative 4 down here and 3 up here. So minus 2 maps on to 3. So when x is minus 2, it maps 1. So this is where it touch. So 3. So minus 2 is mapped onto 3. Minus 1 and 2/3 is mapped onto 0 because that is on the 0 column here. Minus 1 is mapped onto negative 4. So where I have minus 1, it goes to negative 4. And a third is also mapped onto 4. And 1 is mapped on, this one right here, it's very small, is mapped onto 0. And 1 and 1/3 is also mapped onto 3. So in this relation, we have many-to-one relation. So we have more than one values mapping onto one coordinate. Okay? So we can write this quadratic function. So we can rewrite this quadratic function f of x is mapped onto 3x squared plus 2x minus 5. Or we could say f of x is equal to 3x squared plus 2x minus 5. And this will give us our function for this relation diagram. So this was a case where we have many-to-one relation. So we showed one-to-one relation, we have many-to-one relation. Okay? The only relation that is not a function is one-to-many. So I want you to make a note of that. So many-to-one, one-to-one are functions, but one-to-many is not considered a function. So you're going to write that. One-to-one and many-to-one are classed as functions. But if you ever have a table and it plots a graph where you have one-to-many, then we don't have a function, not a function. Okay, so if we have elements where we have a plus and a negative value, we are going to get a one-to-many relationship, right? And we could have we wouldn't get a function, sorry. So let's say I have 0, 1, 4, 9, 16, 25, and 36. And on my, this is my x, and on my y side now I have -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. From the look of that, I could tell you they're going to have one-to-many, right? So when we plot the relations between this now, we can see that 0 maps on to 0, 1 maps on to 1 and -1, right? So you see how 1 mapped onto 1 and -1? This shows one-to-many, and this is not a function. Okay, so every time you see where 1 is mapped onto many, always remember it's not a function. So 1-to-1 and many-to-1 are considered functions. For the rest, 1-to-many are not a function, right? So now that we sort relations, we took a relation, a domain, plot a table, did a graph, determine the relationship diagram. We determine whether they are function or not. We are now going to actually get into functions, and we're going to look at the image of x. Okay, so we're going to take a little note. I'll explain after I write. So remember, you pause the video and write. So the note says, for a function of f and any element x in the domain of f, the image of x is denoted by f of x, where x is any y equals, where x, sorry, this is supposed to be and, so where x and y is equal to f of x, okay? So x and y is equal to f of x. And we're going to look at some examples, which will clear this up a bit. So example 1. If f of x is equal to 2x squared minus 3x plus 1, determine the value of each of the following. 1, f of minus 3, 2, f of 0, and 3, f of 2. So for the function f of x is equal to 2x squared minus 3x plus 1, determine the value of the following. F of x is f of minus 3, f of 0, and f of 2. So where in this formula, f of x is equal to 2x squared minus 3x plus 1. Wherever we have the x value, we are replacing it with minus 3. So f of minus 3 is equal to 2 minus 3 squared minus 3 multiplied by minus 3 plus 1. When we break it down, we're going to get 2 by 9, add 9 plus 1, 3 by 3 minus 3 by minus 3 is 9. 9 by 2 is equal to 18. 9 plus 1 is 10. We're going to get 28. Hence, f of negative 3 is equal to 28. This is basic substitution. Once you can do substitution in maths, this is what you're doing. All the values of x, you are going to substitute it into the formula that they give you, where f of x is 0. So always write back your formula just to be on the safe side and to explain clearly what you're doing. And f of 0 is equal to 2 by 0 squared minus 3 by 0 plus 1. This will mean everything here is 0 and everything here is 0, and we're going to end up with 1. Okay, so f of 0 is 1. In this side here now, everything that is x is going to be 2. So we have f of 2 is equal to 2 squared minus 3 by 2 plus 1. 2 by 2 is 4, so 2 by 4. 3 by 2 is 6 plus 1. We're going to end up with 8 minus 6 plus 1. And this will lead to 8 minus 5, which is equal to 3. So f of 2 is equal to 3. In this case here, I forgot to write f of 0 is equal to 1. So again, basic substitution. Okay, so this is a basic substitution. You can get f of x, g of x, anything, right? Now there's an alternate way this question can come. And I'm going to put it here now. So the alternate way of getting this question looking at this example, example 2. If h of x is equal to x squared minus 1, for what values of x is h of x equals 8? So basically, it's restructured. So if h of x is equal to x squared minus 1, for what values of x is h of x is equal to 8. So given that, so we're going to work it now. Given that h of x is equal to x squared minus 1 and h of x is equal to 8, then we can say, from a little common sense, x squared minus 1, which is this here, is equal to this. Because if h of x is equal to x squared plus 1 and h of x is equal to 8, then we can say x squared minus 1 is equal to 8, right? And then we can say x squared is equal to 8 plus 1. You want to shift this over here to make the subject. And x squared is equal to 9. If x squared, then we can say x is equal to plus or minus the square root of 9. So x is equal to plus or minus 3. Right? So we get two values of x. So x is equal to positive 3 and x is equal to negative 3. So this just tells us that it just reshuffled. They didn't tell us substitute x in it or find h of 5. They tell us h of x is equal to 8. And if h of x is x squared minus 1, then x squared minus 1 is equal to 8. And if we want to find the x value, we just work it like equation. Now we come down here and we meet a square root, right? In order to get rid of the square root, we have to square this number. And when we square this number, it's going to make two numbers, a positive and a negative figure. Hence, we get two values for x. Right? I know some of you may be thinking she mad, but this is how it's done. So what I want you to do now is look over the video as much times as you want. And I want you to complete all the exercises that I posted for you on this. And we will wrap up this topic further in class. For those of you who write in the exam and preparing from it, this is actually the gist of what you need to know, okay? So thank you for watching this video tutorial. I hope this topic was cleared up, and this topic will obviously go in more detail when you do the questions. It's all about practice. So continue working, pause making notes, and very importantly, do the questions. Thank you.